Let's say you have a set of tables and data should be archived based on cutoff date, and this cutoff date is not fixed like 7 days or 10 days. It is provided by the business group as needed. As a development team or as a support team member, you don't have the delete grants on this production dataset. Since these tables are business critical, the project owner wants to make sure that any direct delete grant should not be given to any team member and restricted to only the project owners. To handle a scenario like this, where you have to perform some complex checks and execute a bunch of SQL statements on different tables, including error handling and also certain operations like update or delete without sharing the table privileges with everyone, a stored procedure is a feature provided by Snowflake along with callers and owners' right comes handy. Procedure is a procedural language that helps you to build programming construct including branching, looping, and error handling. And it also includes caller rights and owner's right concept, which is very powerful to protect and allow controlled operation without much worry. Every other database and data warehouse system has a stored procedure. So what's different in Snowflake and why it is important for you to understand and leverage its power to make your data project successful. So let's review these questions, and this chapter will answer all of them in detail. So what is caller rights and owner's right? Can I write Snowflake stored procedure in JavaScript scripting language? Can I write it in Java or Scala too? If so, how can I use it via SQL? Java or Scala code gets converted into SQL? How does transaction management work in Snowflake stored procedures? What is the limitation of stored procedures in Snowflake? So, if you want to build a solid understanding of the Snowflake stored procedure and how different scenarios can be solved using stored procedure, stay with me until the end of this video. Alongside theory, I will also demonstrate everything live. Welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake data professionals. The last 20 episodes in this series already covered history to architecture, data loading, micropartition, time travel, cloning, stream, task, role and role hierarchy, and many more important concepts. This episode, the episode 21, is divided into 3 parts. The first part of this episode will primarily deep dive into stored procedure and how we can use JavaScript as a programming language to build complex business logic. We will also understand how the owners and callers right concept works in Snowflake when it comes to the stored procedure. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all the concepts listed in this slide. Before we move to the next section, I have an important question to ask. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I think you should be. There is a lot of great opportunities out there if you know Snowflake Cloud Data Warehouse. I have been adding a lot of videos to help the Snowflake community to learn Snowflake besides Snowflake certifications. The feedback I got from my audience way high than my expectations. Folks are getting certified at first attempt and scoring close to 100%. Data engineers, leads, architects, and even data managers are learning from my free content. You don't need to buy any expensive courses. Check my playlist. It includes complete hands-on Snowflake guide, SnowPro certification guide, important mock questions for certification, key SQL function series, Snowflake Python and connector series, and many more videos are on your way. So press the like button if there is anything valuable in this video for you. So let's start with a very simple stored procedure and we'll jump directly to our Snowflake web UI and understand its construct. Now first, I'm going to create a customer table with some basic fields. I'm going to insert 5 sample records into this table. So I got 5 records inserted. Let's validate the customer data quickly. All looks good. So this is my stored procedure construct and it says create or replace procedure, the name of the procedure, and it returns a string data type, and language I'm using it here, JavaScript. It is a very strict and execute as a owner. We will try to understand what is the meaning of each of this parameter when we get back to the theory. And finally, this is the body of the stored procedure, which execute a simple statement, delete from the customer table where customer status is inactive. So we have one customer which is inactive, and if I call this stored procedure, this customer ID 102 will be deleted through this stored procedure. So let me first create this stored procedure. So my stored procedure created successfully. Now to call the stored procedure, I have to use a keyword called call followed by the stored procedure name, and if it takes parameter, then you will provide the parameter or argument to this stored procedure. But before that, let's describe the stored procedure and see how the result looks like. So I can use keyword describe or disc followed by procedure keyword and followed by the name of the procedure. So this is a property which it returns. It says that it has a signature which does not have any input argument, and it returns a varchar. Language is JavaScript and few other parameters. The seventh is body, and this is how it looks like. Now I can also use show procedure followed by the procedure name, and let's see how does it look like. This is the name of the procedure. This is the schema, and this is not a built-in stored procedure and some other attribute, and it says minimum and maximum number of argument. If you have not given any description, then by default it takes a description called user defined procedure. So this is how you can use the show command to get additional detail about the stored procedures. Now let me run this stored procedure. The stored procedure is executed successfully, and it must have deleted one record from the table. Yeah, so record number 102 is missing. This simple it is. Now, when we ran the stored procedure, it actually returned the value, but that value cannot be captured in a variable or any other thing. So if I'm going to write this statement on line number 61, where return value equals to purge inactive customer, let's see what happens. It ends in an error because this has to be used only with a call keyword. Now, if you do not know how this variable works, then probably you can follow my SQL playlist, which covers everything about how to use variables, including context functions. So how would you capture the result of a stored procedure? For that, we can either use result scan or we can use a result scan along with a variable. So let's try it out first. So I'm going to call this stored procedure. It will not do anything, but it will simply return static string. And then here I am using the result scan followed by the last query ID, which is this query ID, and let's see what does it return. So I got my inactive customer purged result in a form of a table. Now how to put it in a variable? Let me show you. I'm calling the stored procedure because I am using the last query ID. And then I'm going to call this statement on line number 68. So the result is stored in my value, and then I can use select $my value. And then I can use throughout my session this $my value. Again, if you have not seen my SQL playlist, I would highly recommend to go and watch my SQL playlist once you complete this video. So we have seen how to run one single SQL statement. Let's say if I have a lot of SQL statement and I want to run them one after another, what should I do? It's pretty simple. Here, I can write multiple SQL statement one after another, and the stored procedure will run the collection of statement. So what this procedure does, it simply delete all those customer which are other than active. So inactive, blocked, and unknown. Now there is a table called procedure inside your information schema, and I have a specific intent to show this table. So we have created two stored procedure. One is called purge inactive customer, one is called purge non-active customer. Both are owned by system admin, and none of them takes any argument, and the return type is a varchar here. So there are two additional fields which is available here, okay, which captures this maximum length of the character. You have three additional fields in case if you are returning a numeric data type. Both the procedures language is JavaScript, and here is the body, and the comment we have not given any comment, that's why a comment is null here. However, when you run the command show stored procedure followed by the name, it will show a default comment called user defined comment. Let me show you. So here you can see the description or a comment captured as a user defined procedure. However, this is a default value, not a value given by the user. Now moving to another example where you would like to pass an input parameter and then run the stored procedure, and how to use this input argument in the SQL body. So here it is again the same procedure name called purge inactive customer, and I am taking one string, and whether you can write varchar or a string. So here my input type is in parameter and the data type is a string, and return type is also a string. It is a JavaScript, strict, and owner. Now here you see in the line number 118, I am using this input parameter through a concatenate function. It's a pretty standard concatenate function here. I will elaborate the concatenate function later in this video. Now, one important thing to notice, if you see this, the input argument is in a lowercase. However, in the line number 118, I have put it in a uppercase. JavaScript is a case sensitive language. However, SQL is not a case sensitive. And what Snowflake does is Snowflake converts all this variable into a uppercase. And that's why when we use the variables or any input argument in our body, it has to be in the uppercase. So this is a simple example where you can use input parameter. You can use any number of input parameters and your stored procedure will work perfectly fine. Let me create this stored procedure. So my stored procedure is created successfully. And now I am going to describe this stored procedure. Now, one important thing to remember, when you put the name of the stored procedure with the describe SQL command, you also have to specify the input type, because you can really override your stored procedure with a different data type. This is how I can describe with a string. However, Snowflake also understands varchar and it prints the same stored procedure with the same detail. Okay, now let's create a stored procedure. Primary intent with that example is if the return type is number in the case of SQL or a JavaScript, how the information schema captures this detail. This is a very simple and dummy stored procedure and it returns a number with a decimal precision of 3. So I executed this stored procedure. Now, when we write the same stored procedure in JavaScript, it also does the same thing. However, in place of a number, we are using a float because the data type which matches with a number is a float in JavaScript. Here I am executing this dummy stored procedure. Now let's go and see how the procedure table looks like under the information schema. So if you pass any input argument, this is how the information schema captures the detail. So if the return data type is a float or a number, this is how it is captured. In case of a SQL stored procedure, what I have noticed, the numeric precision fields are captured here. So let's go back to theory and try to understand the construct of stored procedure in Snowflake to reinforce our understanding. We have seen a very simple JavaScript and SQL stored procedure, how it works, and understood how to list and describe a stored procedure. Now let me walk you through the stored procedures construct and explain what are optional and must option and possible values for these options. Here is a sample stored procedure construct, and this stored procedure is using JavaScript as a programming language for stored procedure body. The object creation start with a standard keyword create or a replace procedure followed by the procedure name. The keyword like or replace, comment, execute as owner are optional. So it takes default value if you have not specified while creating your stored procedure. After the keyword procedure, you have to give the procedure name followed by the input parameters, where parameter name must be defined first followed by the data type. In this case, the procedure name is purge data and table name is a first input parameter and it is of data type string. You can see that user provided values are marked in a different color like comments, execute as owner, and stored procedure body. Stored procedure always return a value and the return keyword along with return data type is a must in the definition section as highlighted. However, it is not must to have return keyword in the procedure body. The default language for stored procedure is SQL, and if you are writing a JavaScript based stored procedure, in that case you have to specify JavaScript as a value for the language parameter in the stored procedure definition. As is a must keyword and has to be there before stored procedure body start. Finally, your stored procedure body will appear with $sign. There are some variation if you use Snowsite Web UI, but I am following most commonly used approach in this video to define a stored procedure body, and I will demonstrate you what do I mean by that. If you don't specify any return keyword in the stored procedure body, it is not an issue and Snowflake will automatically take care of it without any compilation and execution error. However, when you call the stored procedure, it will always return a null value. Let's quickly see what all parameters or keywords can be omitted. So this is my bare minimum stored procedure. What does it say? Create or replace procedure followed by the procedure name. It returns a float type and it's a JavaScript type stored procedure. And within that $, it has only one statement, return 2.12. Let me execute it. So my stored procedure created successfully. And when I call this stored procedure, it has returned 2.12 as the return value. Now let's create a stored procedure by omitting the keyword return from the definition. So here I say SP without return keyword, and I have removed the return keyword from here. Let's see what does it say. So it clearly says that the stored procedure definition is missing return types. Now what if I omit the return type from the stored procedure body? Let's see that. So here I have another stored procedure. It is having a return type float and language is JavaScript and body is not doing anything. Let's run that. So it got executed successfully, and when I call that, it is returning a null value. Let's see how the Snow site and legacy web UI works differently when it comes to the SQL stored procedure. So I'm going to create a stored procedure which returns a number, and it is a SQL type stored procedure. And here when I'm writing SQL stored procedure, I have to use the keyword begin and end along with the dollar sign. Okay, let me run that. This got executed successfully, and let me call this stored procedure. So I got 2.120, perfectly fine. Now I have copied the same stored procedure in my Snow site, and here I can really remove this double dollar sign because Snow site has a very different style of interpreting the SQL stored procedure. So here I can execute the same stored procedure without double dollar sign. So this is one of the key difference. Let me execute it. I can click my cursor anywhere and press the run button. And what I observe is Snow site automatically identifies start and end line of the stored procedure without any dollar sign. So this is one of the major difference when you are building stored procedure in legacy web UI, or you are building stored procedure, especially in SQL using Snow site. So keep it in mind. One more thing I would like to show you about procedure. In legacy web UI, we have no menu where I can go and see the registered stored procedure. However, in Snow site, it is possible. For that, I have to go back to home, click on data, click on my database and schema, and I can click on procedure, and you can see all the procedures are visible here. I can click on any one of them and it will show me the entire definition. The argument, result, aggregated, table function, secure, language, followed by the procedure definition. And the different role having privileges to this stored procedure. Everything is visible in this screen, and it is very easy to go grab the definition of the stored procedure from Snow site. There is another parameter which Snowflake allows in case you have a specific requirement for input parameters being null or strictly not null, and the SQL body should run or should not run in the respective scenario. Let's say if you would like to purge a table, without table name, the procedure should not execute any SQL statement in the procedure body. In that case, you can use this optional parameter return null on null input or strict. This is how this parameter looks like. This is the default option, and what does it say? That the stored procedure can be called with null input. Example, call purge underscore data, and in the bracket you can give null, and this stored procedure will work successfully, and it will also execute all the SQL statement within the double dollar sign. But what if I have to make sure that input should not be null and it must have a value, else it will not execute those SQL statement given within the stored procedure body. In that case, I can use a strict keyword or returns null on null input keyword, and stored procedure body will not be executed and it will return null values. So example, if I give call purge underscore data and null, the stored procedure body will not be executed. However, stored procedure will be executed without any error. So this is one additional parameter Snowflake stored procedure provide, which helps you to control the execution of stored procedure body based on null or not null input. Let's see it in action. I'm going to create customer 03 table and insert some record. So I have total 7 records from customer 1 to customer 7. I'm going to create a stored procedure which says purge not null customers, and it is taking an input parameter. Here I have not specified whether input parameter can be null or cannot be null. And what it does, it says customer status is null. Let's see how many customer is having status null. So there are 2 customer which are having status null, which is customer 6 and customer 7. So this stored procedure is created successfully. Now let me run the stored procedure by calling it. So since I am passing a null value, so it says all customers having status null got purged. Let's validate that. So I can see my customer 6 and customer 7 deleted. Now I'm going to insert those records once again. So I got my customer 6 and customer 7 back. Now this time I have added this extra line called strict. What does it mean? If the input parameter is null and this parameter is available as strict, then the body will not be executed. Let me demonstrate this. So my stored procedure got created successfully. Now again I am calling the same stored procedure purge not null customer, and this time since I am passing input value as a null, the definition has a keyword strict, this body should not be executed. So it got a null return. However, in earlier case, I was getting all customers having status null purge. Now let me describe how this stored procedure definition looks like. So it says returns null on null input. Even though I have given a word strict, it has taken returns null on null input. If you have a use case where you want to run the body of the stored procedure only when the input parameters are not null, then you can specify this parameter and make sure that you meet your requirement. If you have worked on Oracle or SQL Server stored procedure, there you can have inline or a block comment. However, I'm not sure if it has a parameter called comment or a description. Snowflake provides comment as a parameter, and you can explain the purpose of stored procedure and its intent. Inline comment can always be given while writing SQL blocks within the $$ sign. Most of the parameters and its value does not have any equal sign operator. One common mistake developers do while writing the stored procedure that they don't give this equal sign for comment parameter, and it ends with an error. And let's simulate it in our legacy web UI. Now in the next stored procedure, I have given a comment, the comment for stored procedure, and let me run that. Here I have done a mistake. Generally, a developer assume that since return takes a string, language takes a value JavaScript, comment should also take a comment. However, it uses assignment operator, and which is equal to here. So the same thing got executed successfully. Now I will go and try to describe the stored procedure and list the stored procedure. I do not see any comment, looks good, but in the body, I can see my inline comments. Now here, when I list my procedure, I can see the comment for stored procedure. So if you have to capture the comment for stored procedure, you have to use show procedures followed by the procedure name. And if you have to see other properties of the stored procedure, then you have to describe. Let's quickly discuss about the parameter volatile and immutable. We call a function immutable function if it satisfies number one, if given the same input value, the function returns the same output value. The number two condition, the function has no side effect. Snowflake stored procedures are not function in a true meaning like a UDF. So this definition and explanation given by Snowflake does not make much sense to me. We write a stored procedure which deletes some record on a status criteria, and there is other process which again insert record on the same table, and when we run the same stored procedure with the same status flag, it may delete more or less record, and record count may vary from time to time for the same given input. So this parameter volatile and immutable with respect to stored procedure is not super clear when and how it is going to be used. And even Snowflake documentation does not throw a very real example. It is more like a marker parameter for reader or a development team that this stored procedure does same thing over and over again with the same set of record for the same input parameters. Let's quickly see volatile and immutable parameters. I'm going to create a customer table and insert few record. So I created a table called customer 5 and inserted 5 records. All looks good. Now here I am creating a stored procedure called immutable stored procedure. What does it mean? That no matter how many times you call for a same parameter, it will always return the same result. Okay. And what it does, it simply deletes from the customer 05 where customer status is in parameter. So I executed that stored procedure, and let me describe the stored procedure for you. So here it says it is immutable. If I recreate the stored procedure by omitting this parameter, let's see what does it take. This time it is volatile. So this is how this parameter changes. So I created the stored procedure once again, and now I am going to call the stored procedure by passing a parameter called inactive. It means all the inactive customers will be deleted, and let's see how many inactive customers we have it. So we have one inactive customer, and this customer should get deleted. So the stored procedure got executed, customer purge as per the requested status. Good. Now I can see only 4 customer in my customer table and the inactive record got deleted. Now I am going to insert few more customers 6, 7, 8, 9, and all the customers are inactive 6, 7, 8, 9. Now let me run this stored procedure. Since it is an immutable stored procedure, I am passing the same input parameter. It should actually delete one record. However, that record doesn't even exist. So it deleted total 4 record. Even if I capture the number of record deleted, it will be 4 compared to 1 in the last execution. At this stage, this parameter is relatively confusing for me, and I assume that it is more applicable for UDF or function rather than stored procedure. So please, if you find any valid use case for volatile and immutable, put in the comment section what is your use case and show me the demo. Let's understand the input parameter or argument case sensitivity concept. If you are writing stored procedure using Snowflake SQL scripting, the input parameters are case insensitive. But if you write a JavaScript stored procedure, then input parameters used in SQL body must be used with uppercase. Else, your stored procedure will end up with an error. So, in this example, the input parameter or argument is table name, which is of string data type. If we assign this input parameter to a variable with lower case as it is shown here, then it will end up with an error. And we must use input variable name in uppercase. So there are two lines. The first line is incorrect and the second line is the correct usage. Since Snowflake converts all SQL object names in uppercase, that's why when executing JavaScript stored procedure as a body, it expects that all the parameter name should appear in uppercase. Let's see it in action. So I'm going to create a customer table, insert some record, and then I will create a stored procedure. So I got a customer 06 and it has total 7 records. Good. Now I am creating a stored procedure which takes one input parameter, and this input parameter is used to check whether customer status is matching with that input parameter or not. If yes, delete all those customers. So delete from customer 06 where customer status equals to input parameter. Here, when I have specified the input parameter, it is in the lower case. The language for the stored procedure body is Javascript. So during the stored procedure creation, it got executed successfully. Now let me run this stored procedure. So here I am calling sp underscore lower underscore case by passing inactive as a parameter. Let's see what happens. So it says uncaught references error, in parameter is not defined. Why in parameter is not defined? Because in parameter is in a lower case and Snowflake expect input parameter in uppercase. Let me fix it. So now I converted this into uppercase, and let me create the stored procedure once again. Now let me first check. I still have 7 rows and I have total 1 inactive record. Now when I call this stored procedure, this should work properly. All good. Now I can see I have a total 6 records. However, when I create the same stored procedure with SQL statement, I don't need to specify uppercase and lowercase. For SQL, it is case insensitive. Let's understand the stored procedure body, which actually gets executed when stored procedure is called. After the as keyword, you write your stored procedure body. If you are writing JavaScript stored procedure, then your stored procedure definition must be enclosed with a string literal delimiter, which is either single quote or a double dollar sign. When you don't have any single quote in your stored procedure body, in that case you can use single quote as a string delimiter as shown here. But when you have a single quote in your stored procedure body, in that case using single quote as a delimiter will not work, and then you have to use double dollar sign as a string literal delimiter. Let's see them in action. So I set my context and this is my stored procedure with single quote. So if you see the body of the stored procedure, it does not have any single quote. So what I can do, I can really use a single quote as a delimiter and followed by a semicolon. This is a very simple stored procedure which does nothing, simply return an expression. Let me execute it. This got executed, and before I call that, let me describe it. So I can see my body is just having this text. Now let me call this to make sure that it does not have any runtime error. Good, I got this result 69, which is expected. Now, if you look into this stored procedure body, it has a single code. It means that I cannot use a single code for this stored procedure as a body delimiter. So I can use only the $$ as a delimiter. It got executed, and let me describe this. And I can see the body does not have the $$ because that is just a delimiter where it is starting and where it is ending. And it captures everything within that $$. Let me execute this. So I can see this SP02 does nothing. So if you use SQL scripting, in that case, you don't have to use the double or single dollar, and we have seen that in Snowsite. One important thing to remember, the JavaScript stored procedures are not validated, and this is done only during the runtime. So if you make some mistakes, it will just go appropriately. However, during the runtime, it will throw an exception or some kind of compilation issue. We have written some simple and straightforward stored procedure. Let's write little more complex stored procedure and try to understand those JavaScript API within the stored procedure body. If you feel little lost, just be with me. So let's switch the context first. I'm going to create a customer table and insert few records. So I got 5 rows in my customer table, looks good. Now what is the requirement for this stored procedure? This stored procedure says get customer name as a string. It will give cust1, cust2, cust3, cust4 one by one as a single string. Okay, so this is the purpose of the stored procedure. It is going to take status as a string. So not all the customers I want to consider. I want to only consider a specific customer or active customer. This returns a float type for now. I can change it to a string. So this returns a string type. Body of the stored procedure is written in JavaScript. So it will start with a $sign. So I have defined a return value called return value. We have to use a keyword called variable. So this variable will be available throughout my body. Now I have created another variable called SQL query, and it takes this status and build the dynamic query. So the dynamic query will be select salutation first name last name from a customer table where customer status is equal to status, inactive, active, and all those things. Now we are executing the query using Snowflake JavaScript API, and this Snowflake object is automatically available in your stored procedure. And in this Snowflake object, I am calling a function called create statement. This function takes a JSON object. A JSON object is nothing but a key value pair within curly braces. So I can really shrink it. So this is how this parameter looks like. So what it says, it is taking a key called SQL text, and actual value of the SQL query is coming from this variable. This is SQL statement object returned by this function call, and on this SQL statement object, I am calling another function called execute, actually executing the query. Now once the query is executed, I will get another object called result set, which I have named it here as a result scan. You can give it result set, RS, anything. Now once I get this result set, my stored procedure from line number 53 to 57, it will iterate through the result set and try to capture all the column value. If you have ever done any JDBC or ODBC programming, this programming looks very similar to that. So here from the result scan, I am getting column value 1, column value 2, and column value 3. And if you look, I have total 3 columns in my select statement, and this 1, 2, 3 corresponds to them. And finally, once my string is constructed, I return this value. So this is how my stored procedure looks like. Let me run this complex stored procedure for you. It got created successfully. Now let me get the result first and show you. So here I say Mr. Customer 1 L name, Mr. Customer 4 L name, because these are the only 2 active customers. So my stored procedure is working properly, and you have understood at very high level how I can use JavaScript API. Now let's change this example with bind object. So there are minor changes done, and I will only highlight the changes. So on line number 80, where I was concatenating the status variable, here I have given a question mark. So it says select salutation first name last name from a customer table where customer is equals to question mark, and I am going to replace this question mark runtime through the bind object. I am calling create statement from this Snowflake object, and now I am passing 2 parameters. One is called SQL text as equals to SQL query, and here I am using another keyword called binds, which takes the status which is coming from the input parameter. Rest of the SQL statements are exactly same. Let me execute this stored procedure. So this got created successfully. I'm calling this stored procedure and let's see the result. So I got the same result. So let's summarize what we have done in this complex stored procedure. We created a global variable called SQL query, and using plus operator, we constructed a dynamic query. This dynamic query took input parameter from stored procedure argument list and concatenated it to construct a query. Since it is a JavaScript stored procedure, we used uppercase of the input parameter. Next, we use Snowflake JavaScript object and created a statement by passing a JSON string. You can see the JSON string with a curly braces and having a key value pair with colon. You can pass n number of such key value pair delimited using comma. Once it is done, we called execute function from the statement object that returns a result set object. Now we can use this result set object, which is named as a result underscore scan, and iterate it through and capture it or use it as we want. And finally, we return the value. Make sure that all the stored procedure body content should be with the double dollar sign, and the double dollar sign ends with a semicolon. Each of the logical statement within the stored procedure body should also end with a semicolon. You can have any number of inline comment using 2 forward slashes to document your stored procedure logic. So this is a basic structure of stored procedure, and you can add more and more code to build a complex and a very sophisticated business use case. We have also seen how to use the bind. So either we can use the concatenate function or we can use the bind operator. The advantage with the bind operator is that you don't have to worry about single quote and all those complexities. You take the input, use the question mark as your placeholder, and during the create statement, you bind all your variables, and Snowflake will take care of using single quote and all the necessary complexities on your behalf. So let's talk about multi-line string and its continuation to the new line. There are cases where I have to write a string in a multiple line. In that case, I would prefer to have the line continuation supported by Snowflake. Snowflake follows 3 different approaches. Let's quickly discuss. Approach 1, put a backslash, and in that case, you break your line using a backslash, and that way you can split your long string into a multiple line. So this is one way. Second approach is called backtick. So you start with that string backtick and you end with a backtick, and you can write any number of lines between that. And the third approach we have followed with any other programming language is that plus and equal to operator. Okay, so where we accumulate the string, and this is how the example looks like. So if you have a requirement where you have to break your long string into a multiple line, you can follow any one of this approach and it perfectly works within the double dollar sign in your stored procedure. Let's understand what is owner's right and what is caller's right. If you don't understand the Snowflake's object security model, which is called discretionary access or role-based access control, you can watch my previous chapter, chapter 20, which covers this concept in detail. Let's see this stored procedure called complex SP. This stored procedure is trying to access different table data which exist in a different context, means under different databases and under different schemas. It is also trying to use some user-defined function which exist in a context util.function. Now, this stored procedure is calling another stored procedure that also exists in a different database and schema. This stored procedure is using a parameter called execute as caller. And what does it mean? Whichever user call this stored procedure and the role user has, that role must have necessary grants and privileges to use these tables and other objects which stored procedure is trying to access and perform different operation. If the user's role, which is calling this stored procedure, does not have enough privileges, then this stored procedure will fail with privilege error. Even if owner has really validated the stored procedure, the caller will end up with privilege error. Now let's assume that this stored procedure is created by a user who has lead role, and there is another user who has analyst role wants to run this stored procedure. This stored procedure will take the analyst role as a current role and run the stored procedure. Analyst role should have enough privileges to run those individual SQL statements, else it will end with an error. If you don't want to give any grants to the caller, to the individual object, and wants the caller should use owner's privileges in grants, then you can change this value from caller to owner. Even if you don't specify this statement, the stored procedure considered owner as a default value. That is how we can solve many use cases without giving access to any other user and control everything through the owner's privileges. So to get a better clarity, let's jump into our web UI and see them in action. I am back in my web UI and I'm going to demonstrate how this owners and callers right works. It's going to be a little complex exercise. Stay with me and follow me closely. I'm going to create a couple of objects, roles and users to show you entire simulation through this example. So I created three schema, schema 1, schema 2 and util. Also created ad hoc warehouse. Now I'm going to create table 1 in schema 1, table 2 in schema 2. So let's see how many tables I have it under schema 1. So I have only one table called table 1 under schema 1. Now switching the context to schema 2. And I have table 2 available under schema 2. Looks good. Now let's select and see how the data looks like. So it is just a sample data like country and ISO code. And table 2 also has country name. So this is join query which joins two tables from two different contexts. So this is how the result looks like, and this query I'm going to use it in my stored procedure to simulate owners and callers right. Now I'm going to create two roles, two users, and for that I am switching my role to the security admin. If you have not seen my chapter 20 which covers role-based access control, please watch that. So as per Snowflake best practices, all the role must be created by security admin. So my role is changed to security admin. I'm going to create two roles called project lead and support lead. Now I'm going to create two users, and to create a user, I'm going to use account admin role. So I'm in account admin privilege. So this is lead 01, and I'm assigning that project lead to the user lead 01. I'm creating another user called lead 02 and assigning role support lead to lead 02. Going back to my security admin role, and here I'm making sure I create a role hierarchy. Security admin will get the project lead role and project lead will get a support lead role. So the role hierarchy is created successfully. Now let's validate how our role hierarchy looks like from our Snow site. And I go to the roles tab, and here I can see I have a support lead which has one user, I have a project lead which has one user, and this is how the role hierarchy looks like. So whatever support lead can do, project lead can also do, and whatever project lead can do, security admin can also do. So this is how the role hierarchy is here. Now let's grant different privileges to project and support lead role, okay, as per their responsibilities. And for that I will first switch to the system admin role. Let's give a usage grant to the database. Both this role got usage grant on tipsDB. Allow them to use warehouses. So both the role can use warehouses. Now project lead can use schema 1, schema 2 and util. However, the support lead has access only to the util schema. This is what the restriction I am putting it here. I'm going to give all table access to project lead under all the schemas. So this got executed. However, support lead can access only the tables from util schema. Now all the objects are created by system admin and all the necessary privileges are given to the role project lead. Let's access the user lead 01 who has a project lead profile. Since we are accessing first time, the Snowflake is showing a welcome message. Let me minimize it quickly. So by default, I have got a public role and I can switch to the project lead role or a support lead role. So let me first switch to my project lead role. Let's change the context explicitly for this worksheet. Since I have all the privileges as a project lead, I managed to set my context properly, like project lead, ad hoc warehouse, ttips database and util schema. I'm going to create a stored procedure which calls SP with callers. Okay. So this procedure will take the caller's role and then it will execute the SQL statement. The SQL statement is pretty simple. This stored procedure has two sets of SQL statement. First, it is trying to understand what is my current warehouse and what is my current role, because I want to make sure that this message is passed as an output. And then it is having this multi-line query. You can see that I have used backward slash to create a multi-line statement. And finally, it is executing this SQL statement, and this SQL statement is trying to make sure that it is accessing data from the different tables and finally giving the result. And I'm executing this statement. And if this statement goes good, and I'm concatenating all the result through this return value, and let's execute and see how does it work. So right now, the project lead is creating the stored procedure. So project lead becomes the owner for the stored procedure. So my stored procedure is created successfully. So I can see SP with collars. This is created and this is under util schema. Okay, this is how it looks like. And if I want to see who owns this stored procedure quickly, I can go back to my Snow site. And I can see the ownership belongs to project lead. Okay. Since project lead is the owner of the stored procedure, project lead can give usage grant to the support lead role. Okay, and how I can do that? I can say grant usage on procedure SP with collars to role support lead. It means that support lead role can also access this stored procedure and use this stored procedure. Right now I'm logged in with lead 01. Let me log in to the lead 02, which is a support role. Let me quickly close the welcome statement. And I can see that I am logged in with a lead 02. And I have only two roles, public role and the support lead role. So I switch my role to the support lead role. Let me change my database, schema and warehouse. And let me run my current role and current warehouse. Now my context is fully changed here. Let me run show stored procedure command. So I can see this stored procedure. It means that I should be able to run this stored procedure. I have usage access to this stored procedure, and now I'm calling this stored procedure. I ended with a compilation error because it says support lead role does not have access to the tips schema 1, and that's why it failed, right? Okay. Now let me run this join query. That's what is causing an issue. And it says that I'm not authorized to access this join query. Good, perfectly fine. And this is what I was expecting, that support lead cannot access those tables and those schema and those tables, and that's why we ended up in this error. Okay. Now I'm back with my lead 01 profile, and let's run this stored procedure to see if it works here or not. So my role is a project lead here, and I can simply call this stored procedure. It got executed saying that, okay, your warehouse is ad hoc warehouse executed with role project lead, and this is the result it brought for me. Looks perfectly fine. Good. Okay. Now to make it, now support lead doesn't have access to those tables. How can I enable this stored procedure working for them? For that, I have to change this value from caller to owner. And I will rerun this stored procedure. Since I have recreated this stored procedure, I will give the usage grant again to the support lead role. Now I will go back to the lead 02 profile. Now here again, I am back to the 02 profile, and let me run this statement first. All good. I am still getting an error, but when I run this stored procedure with support lead role, it should work. So I got exactly the same thing, and what it says, warehouse is ad hoc warehouse executed with role project lead, and it gave me the same result. Even though my role is support lead, it got executed with project lead, and that is what the power of owners and the callers write. I hope I managed to explain this overall functionality. This is a very powerful functionality. Without giving all the privileges to the user through the stored procedure, you can really control many things with this owners and callers write. When you write a complex logic within a stored procedure, it is possible that an exception may arise, and stored procedure must be able to handle it. So let's see how does it work in Snowflake. Let's take this example, and this stored procedure is running an invalid SQL statement. We know this statement will not be called because current underscore DBS is not a valid function. The actual function is called current database. We wrap the snowflake.execute statement using a try catch block. So you can see the line number 13 and line number 17. So when we call this stored procedure during the runtime, this line number 14 will get executed. It will throw an error, and that error will be caught by line number 17, the catch block. Now within the catch block, you can use the error object, which is named here ERR, and put the error object to print rest of the information, which can help you further to debug this overall problem. So let's try it out. So I'm back in my web UI. Let me switch my context. Here I have a stored procedure called SP with try catch. And what I am doing it, I am executing this SQL statement which has an incorrect SQL function. And we are sure that this will not work, and we can try that out first. So here it says that current DBS is not a valid one. Okay, so I can wrap this execute statement within a try catch block, and this is how it looks like. So you start with a keyword called try, open braces and curly braces, and followed by a catch statement. Now here, this object is implicitly available within this stored procedure. Now by using this error, you can print error code, you can print error state, you can print error messages, you can really get the error stack trace. So if you are coming from any programming language like Java, Scala, Python, or even JavaScript, you understand how this try catch block works. So this is a very simple syntax about try and catch block. Let me create this stored procedure. It is created successfully. Let's see, does it have any special properties when I have used try catch? No, everything looks as usual. And here is my body. Now let me run this stored procedure and how this try catch really helps me to catch the error. So here I can see that I got this code 2140 state 4206 and the messages, and it says that unknown functions current role and current DBS, and stack trace is line 4 position 20. This is how you can control your overall execution flow using try and catch. Let's say I have another requirement where I have to throw a custom message and drive my flow or the return value. In that case, we can use a keyword called throw and give a custom messages. In the previous example, it was a system error based on the compilation issue, and we do not have a control over the messages which is created by the Snowflake. But in this example, we will try to understand how you can create a custom message and give it back to the caller or a user who is invoking that stored procedure and might have given invalid, not acceptable input value. My requirement is that I would like to understand what all warehouse access user has. If they don't have access to a particular type of warehouse, it will return a custom message. If it has an access to the warehouse, it will return a number. Let's understand the code of this stored procedure. It does a very simple things. It creates a return value. First statement is to run show warehouses, and then the second statement captures the result of this first statement and construct a query dynamically, and finally execute that query using the bind keyword. Let me run this SQL statement outside of the stored procedure and show how does it work. So the first statement is show warehouses. It brought all the warehouses, and this is a query ID, okay? And next is result scan statement, which is trying to compare whether the size, which is this one, is matching with the size provided in the where clause. So it returns to count, in the sense I have two warehouses of size extra small and I have access to it. Now let's run this again and change it to extra large. Let's see what result does it bring. So it brought the 0 record. So when I get a 0 record, I should get a custom message through the stored procedure saying that you do not have access to extra large warehouses using this rule. And this is what I have written in the stored procedure. So this two statement will run. If the value of the result is less than 1, it will construct a custom message, and the custom message will be thrown from the stored procedure. This catch statement will catch it and return the error message. In case if I have access to the warehouse, it will return a successful message like this. So this is how the stored procedure looks like. Let me execute it for you. So it takes one input, return varchar, JavaScript, called on null input. So all looks good. And this is the body of the stored procedure. Now I am going to run this stored procedure with extra large. This should result to a failure or custom message, right? So I got the result, and it says that first SQL statement is show warehouse, second SQL statement is select count, and count result is 0. You have no access to any warehouse of type extra large. Good. However, when I run this statement, It simply doesn't. You have access to two warehouses of type extra small. So this is how I can use try and catch and the throw keyword to really design a complex and sophisticated stored procedure. Now let's understand this custom exception or messages. Snowflake does not allow you to create a custom object. However, it allows you to create a custom message, right? So if you look into this example, what we have already practiced, we threw a custom exception and it is just a string object, and we put a lot of custom messages for this object before throwing the error. It's not actually an error. It's not actually a system error. It is called a business error or a custom error. So this is how you can really build a custom exception or a custom messages and allow your stored procedure to return that message as per the input parameter or behavior of your stored procedure. So I hope this gave you a construct of try catch block, and the throw statement, and how you can design your stored procedure as per your business need and make it more sophisticated and build a robust logic. Let's understand the transaction management in stored procedure and how to start transactional block and commit or use a rollback. This stored procedure is deleting record from two tables called order and the order item table. First, it is deleting from order item table, which is a child table, and then it deletes from the order table, which is the primary table. The delete query at line number 30 has a syntax error to simulate our transaction support in Snowflake. So to support this, first, you have to start a transaction using a keyword begin and then name the transaction. In this example, we have given the name called work. You can give any name as you wish. While executing, the first delete SQL will run without any issue. The second SQL will fail and it will throw an error. Since both the SQL statements are inside a try catch block, a system error will be raised. In the catch block, we need to make sure we roll back the transaction using a rollback keyword and using the transaction name, starting the transaction using the begin keyword. Let's see these things in action. So I'm back with my web UI. Let me switch my context. All look good. So here I am creating order table, order item table, inserting few records, and then finally I will run a transaction in which I will first delete data from order item table, and then I will try to delete data from order tables and roll back the transaction. So let's start that. So this is how my order looks like. 3 records, order ID 1, 2, 3. Order item table is having 2 records for each order ID. Looks good, total 6 records. Now here I am going to write a stored procedure which will purge the data based on the order status if it is failed. Good. And that order status I am taking as an input parameter through the argument. The line number 23 says execute begin work. So begin is a keyword which indicate this stored procedure that start a transaction. Stored procedures are by default auto commit. Now here the first SQL statement will delete the data from the order item table based on the order ID where status is failed. And next statement is delete from the order where order status is failed. And I'm going to remove this single quote. So this statement will fail during the execution. Since the first statement got executed, the second statement fails. Since it is a part of a try and catch block, it will come to the catch block, and in the catch block, I will say roll back this work block. So here my transaction will roll back anything which is done during this execution. Good. If this statement goes good, then it will say commit the work. So this is how this transaction block works within the stored procedure. Let me create this stored procedure. It got executed successfully. Let me describe it. Looks good. This is how the body looks like. Let's call this stored procedure with the parameter failed. So it got failed because there is a SQL compilation issue. Now the biggest problem is that it does not tell exactly what was the SQL error. For that, you have to really print some of this error code and all those things, right? Let me modify that. So I have added some additional text to understand what is actually failing, and let me rerun. The stored procedure is recreated, and let me call it. Now it is clearly saying you can go to the line number 12, position 18. Now how do I know what is the line number 12? So let's try to understand that. So this is probably line number 12, you can see, and this is causing a problem somewhere here. So this is how you can also debug it by opening the describe procedure, and you can go exactly to that line number 12, because the line number 12 on your worksheet might be different, but in the body line number 12 is this line. Good. Okay, now let's fix it and see whether it works or not. But before that, whether the data is deleted from this table or not, let's validate it. So we know order table delete did not go through, so it has 3 records, perfectly fine, and order item had 6 records, so it should be 6 record. Okay, so I still have a 6 record, so nothing got deleted. My transaction blocked with rollback work within the catch part. Okay, now I'm going to fix this. I will recreate this stored procedure. So I can see this has a single quote, looks good. And now I'm calling this stored procedure. It says it executed successfully, all good. Now I will go and check my orders. I have only 2 records. Status with failed record got deleted. Order item, I have only 4 rows because failed item got deleted. So this is how the overall transaction works. You can have multiple transactions, but make sure that you do not make the nested transaction. There are certain conditions when it comes to the nested transaction within the Snowflake stored procedure. The current state of Scala and Java based stored procedures are in the preview version, and I can see some changes coming on the way, and that's what I am going to make a separate playlist for Java based as well as Scala based stored procedure. Now, one question people generally ask, whether this Java based or Scala based stored procedure gets converted into SQL internally. Snowflake documentation does not talk anything about internal implementation and how does it really run in their runtime environment. Let's quickly understand some of the design tips and limitations. It is hard to debug stored procedure in Snowflake as error messages are not very clear and handy and helpful. So you use try and catch block along with error object and try to print all the necessary error code, error message, and stack trace. You cannot use stored procedure with expression. Example, call SP1 plus SP2. This is not allowed. Similarly, call SP1 plus 2 is also not allowed. Another example, that output of the second stored procedure will be input for the first stored procedure. This is also not possible. However, this is possible in your UDF. Stored procedures are not atomic, and if you have to make it atomic, you have to use transaction management. So auto commit is true within the stored procedure. Stored procedures allows recursion and the maximum stack depth is 5. So remember that if you are building a logic which has a recursion, make sure that you design them appropriately, test it thoroughly, and then you apply it in your environment. Calling too many stored procedure causes deadlock. This is difficult to reproduce in some cases, but I have seen that calling too many stored procedure creates a deadlock and it is very, very hard to debug. So these are the couple of limitations, and you have to make sure that you design your stored procedure very intelligently. You don't get into a trouble while building complex data platform and solutions. Though we are going to cover user-defined function in later part, let's understand what is the difference between stored procedure and UDF. Stored procedures and functions both are reusable blocks, but functions are more compute values and does not make changes to the data on which it is operating. However, stored procedure can change data using insert, delete, update operations. Function does not allow any DML operations like insert, delete, and update. Stored procedure cannot be used inline with SQL statement like select, where clauses, and having clauses. However, UDF can be used inline with SQL. Try catch block and transaction is possible in stored procedure but not in UDFs. Function or UDF can be called from stored procedure, but other way is not possible. So these are the very high level differences between stored procedure and UDF, and when you see the UDF chapter in part 2, you would understand the clear difference when to use stored procedure and when to use UDF or user defined functions. There are a lot of things in a stored procedure to consider, and I assume in this short video I managed to throw enough light about stored procedure, the basics of stored procedure, and how does it work with transaction, exceptions, variable, and many other things. Though we have seen a very quick difference between stored procedure and function, but there are a lot there in the function, or sometimes we call it user defined function. So part 2 of this chapter 21 will deep dive into scalar and tabular user-defined function, including system function, function overloading, functions using JavaScript, Java, and normal SQL standard. I hope you have been enjoying this Snowflake learning series. If there is anything you liked in this session, press the like button and leave a comment. And yes, happy learning.